class. Miss you guys. Let's talk about algebra as it pertains to numbers. We're going to do a review of some stuff to kind of start off this unit, sig figs, percent error, and a little bit reviewing the geometry that we've already done so far. All right, so just as a quick reminder, we have our number sets. And we went over this at the very beginning of the year. We have natural numbers. All right, and your natural numbers are your counting numbers, 0, 1, 2, 3, etc. We also have our integers, which is our fancy z. And that's our -2, -1, 0, 1, 2, and it's going both ways there in different directions. We also have our rational numbers. Oh, how about an N there? There we go, rational numbers. And that's our awkward looking Q. Rational numbers can be fractions, they can be repeating decimals, they can be terminating decimals, or they could also be integers. We also have the set of irrational numbers, which isn't really something that we looked at a lot. But knowing that in our irrational, which would be kind of Q prime or not Q, would be things like pi, the square root of 2, non-repeating, non-terminating decimals. Finally, we have real numbers. And that includes all irrational, rational, integer, and natural numbers. So, as we kind of look through these, sometimes we have exact values, and sometimes we have approximate values. And when you have exact values, that's good, but when you don't, then you can end up with something called error. And we're going to talk a little bit about error a little bit later. But first, let's talk about significant figures. Again, this is a review. We talked about all of this at the beginning of the year, but we want to make sure that we're solid on this before we go into calculus. So, rule 1, all non-zero digits are significant. All right? Also, zeros between non-zero digits are significant. Additionally, we have that zeros to the left of the first non-zero digit are not significant. Zeros after other digits, but to the right of the decimal point are significant. So if I look, something like 2,578 has 4 sig figs because I have 4 non-zero digits. 20,004 has 5 sig figs because of my 2 non-zero digits and then my 3 zeros between non-zero digits. However, 23 thousandths has 2 sig figs because the zeros to the left are not significant. But if I have 100 thousandths, that has 3 sig figs because these 2 trailing zeros here are significant. So, when we change the number of sig figs that something has, what we're doing is we are rounding, we are estimating, we're changing things. So let's take a look at what would happen if we were to change the number of sig figs. So let's write 24 and 31 hundredths to 2 sig figs. All right. So right now it has 1, 2, 3, 4. To take it to 2, I round to the nearest whole, which is 24. What if I wanted 1,005 to 3 sig figs? Well, right now it has 4, which means that I need to round to the nearest tenth so that I end up with a trailing 0. Well, that's going to round up to 1,010. 3 sig figs. Finally, let's write 2,981 10,000ths to 2 sig figs. All right, so I'm going to have to round this to the hundredth so that I've only got 2 spaces behind the decimal. 0.30, and because that 0 is to the right of the decimal and it's trailing, it's significant. So there I have those extra sig figs. All right, so next we're going to talk about percent error. Now, percentage error is the, oh, you know what? I ran out of space. Let me flip the page. Percent error starts out with talking about what error is. So error is the difference between an estimated or approximated value and the exact value. That's error. So error, in other words, is the approximate value minus the exact value. Percent error, then, I don't know why that's shaking so much. Sorry, guys. trying to film from home here and I don't have a tripod. Percent error is found by taking the absolute value of the approximate value minus the exact value divided by the exact value times 100%. All right. Now, we do that so that we're not constantly having to like switch things around so that we can make sure that we're getting a positive value. All right, so let's do an example. Let's say that Solomon measures a 125.7 degree angle with a protractor as 126 degrees. Let's find the percent error. All right, well, his approximated value, or the estimated value, is 126. And we subtract that from the exact value, 125.7. Divide by the exact value, 125.7. Take the absolute value of that and multiply by 100%. All right, let's see. So, 126 minus 125.7. And the, let's see, I'm going to divide that by 125.7. All right, now I don't need, the absolute value would make it positive, so there we go. I multiply by 100. And my percent error is 0.23866. And I'm going to round that to 3 sig figs. So my percent error is 0.239%. All right. Now, let's do a very quick review of standard form and geometry. All right. So, when we write numbers in standard form, we have them as A times 10 to the K, where A, actually, let me write that better. I'm just going to say that 1 is less than or equal to A, which is less than or equal to 10, and K is an integer. All right, so if I have a number, you actually might know standard form as scientific notation. So remember that if I'm writing something like this, that's 257 million. What I'll do is I need A to be between 1 and 10 inclusive. So this becomes 2.57 times 10, and what would I need to multiply? How many times would I need to multiply by 10? 1, 2, 3, 4, 5, 6, 7, 8. Well, if I was doing this one in standard form, again, a must be between 1 and 10. So 4.3 times 10, but this time I'm not multiplying by 10, I'm multiplying by 1/10. So this is going to be a negative number here. Remember, integers can be negative. And that would move 1, 2, 3, 4 spaces. So really important is that you know this as scientific notation. But IB may ask you to write it in standard form. Standard form is what you know as scientific notation. Okay, last little bit of this quick review today. We're just going to go over really quickly the distance and midpoint formulas. Remember that midpoint of 2 points is x plus x over 2, y plus y over 2. And that distance is found by taking the square root of x minus x squared plus y minus y squared. All right. I'm going to post a couple of review problems for y'all to do. And in the next video, we're going to talk about algebra and numbers as they pertain to sequences and series. Have a nice day.